So, here we are going to focus on graphing to solve a system of equations. You see over here that I've denoted the y equals 2x minus 1 as the blue line. The red line will be the y equals negative 3 over 4x plus 10. We begin by plotting the point negative 1, since that's the y-intercept, at negative 1 on the y-axis. From there we do the slope. Since it's a positive number, we go up 2, and since there's no number below it, it's assumed to be over 1. So up 2 to the right 1, because 2 over 1, up 2 to the right 1, and that is continued until we are finished with our line. In addition, we also have to go down 2, back 1, down 2, back 1. Our goal is to plot all of these points because we're going to graph two lines and find where those lines intersect, and they should intersect at one of these points. We now take a straight edge. Unfortunately, I can't get a straight edge to work on the iPad, so I'm going to do my best possible. Again, yet another reason why we've plotted the points. And then we connect them and put arrows at the end to show that this line continues on forever. And then we should always label which line this is in a system of equations. So this is a y equals 2x minus 1. Shifting over to the red line then, we start by putting our point at our y-intercept, which we see here is 10. From there we go down 3 to the right 4, and hey, there is our point of intersection where the two lines overlap. 1, 2, 3, 1, 2, 3, 4. I'm going to put one more point. You only need 2 points to make a line. 3 points, however, makes it really, really more accurate. And draw our line through that graph. Again, we want to label what that coordinate or what that equation is. In this case, y equals negative 3 over 4x plus 10. And then our point of intersection. We see then our point of intersection is this green point. And this green point is at 4, 7. That means that 4 is our x, went to the right 4, and up 7. We can verify that is true by plugging those in to check. If we check over here, 2 times 4 minus 1 is indeed 7, as well as negative 3 divided by 4 times 4, the 4s would cancel, so I get negative 3 plus 10, and that does indeed equal 7. Remember these x, y coordinates have to work for both the top and bottom equation in order for this to be true. Since it is, we can say that our answer is indeed 4, 7, or x equals 4, y equals 7. For substitution then, we must have a variable solved by itself. Since this is indeed the case, here we see that y is equal to 2x minus 1. Because of that, this is y, and we can put 2x minus 1 in place of this y. We will then write 3x plus 4 times the quantity of 2x minus 1. Is equal to 40. The benefit of doing substitution here is now we only have one variable. This allows us to actually solve this equation. Now this is just solving algebra. Here we see then that I have 3x. The 4 gets distributed to each part to give me plus 8x minus 4 is equal to 40. Now we combine like terms by putting our x's together. Since they're on the same side of the equals, we do the same thing. So 3x plus 8x, since they're both positive, gives me 11x minus 4 is equal to 40. And from here, we're just solving our equation. So add 4 to both sides. This gives me 11x equals 44. And of course, now we divide by 11 on both sides to get x is equal to 4. Once we have our x equals 4, we can then substitute that into either the top equation, y equals 2x minus 1, or the bottom equation. In this case, the top equation would be much easier since we're trying to find y and it's already got y equals. Thus we have y equals 2 times the quantity of 4, which is the x, minus 1 from the top equation, and that gives me y equals 7. Our last step then is to verify that this works for both the top equation and the bottom equation. It of course has to work for the top, the x equal to 4 and y equal to 7, because that's how we got the y. The bottom equation, 3 times 4 is 12, plus 4 times 7, 4 times 7 is 28. So 28 and 12 is indeed 40, so we know that our answer is correct. Thus, we can make the statement that x is equal to 4 and y is equal to 7, and that works for both equations. So this is our answer. On this slide, we'll use elimination to solve the problem. You must have both a positive and negative coefficient of the same variable. For example then, here, since I have a positive for y, I need this top to be a negative for y if I would like to eliminate the y's. Therefore, what we can do is multiply this top equation by negative 4. It has to be the opposite of the positive 4. When we do this, this negative 4 goes to all parts on both sides of the equation. So this gives me a positive 8x minus 4y equals positive 4. We still have the 3x plus 4y equals 40. Now we add the two equations, x's with x's, so that gives me 11x. Here the y's cancel, and this is left with 44. From here then, we see we're just solving for x. This divides by 11 on both sides. X is equal to 4. Now, just like with substitution, we are going to plug in that 4 in place of either the top equation or the bottom equation. In this case, I'm going to choose the top. You could choose either one. And I'm simply going to solve for y. So 2 times the 4 plus the y is equal to negative 1. I then add the 8, since negative 2 times 4 is negative 8. I do the opposite, add 8, and this gives me y is equal to 7. Checking the bottom one then, we see that 3 times 4 is 12, 4 times 7 is 28, and again 12 and 28 is 40. Therefore, I know that my answer is indeed x equal to 4 and y is equal to 7. And that is my answer. Here are three different possible solutions you can have when you have linear systems, meaning two lines. Here are three possible ways that this can happen. The first scenario, and the scenario you're most used to, is when I have exactly one solution. And this happens when I have intersecting lines. Lines with different slopes will intersect at only one point. The next scenario is infinite solutions. Here we see only one line. We're asking ourselves, where's this blue line that we had? Well, the blue line is actually the same line as the red line. When the two lines are exactly the same, the two equations produce exactly the same line, we call that coinciding lines. Coinciding lines are the same slope, same y-intercept, and what that gives us is an infinite number of solutions. Any point that's on this red line is also a solution to the blue line. So any coordinate that you have for the red line is also a coordinate for the blue line, and this means that there's really an infinite number of solutions from this line. The last scenario we have is no solutions, and this occurs when we can see that our two lines are parallel. Parallel lines, remember, have the same slope but different y-intercepts. When we have parallel lines, then we end up with no solution because they never cross. Therefore, there is no x and y that makes this and this the same, unlike our exactly one solution. So with two lines, you can have these three scenarios. One solution, which happens when we have intersecting lines, meaning that they have different slopes. I can have an infinite number of solutions, which happens when the two equations are the same exact line, meaning they have the same slope, same y-intercept. We call those coinciding lines. And the last scenario has no solution. That happens when my lines are parallel. Remember, parallel has same slope, different y-intercepts. Any parallel lines have no solution to that system of equations. So this is how these solutions are represented graphically. Now let's take a look at how these present themselves algebraically. Here we're going to solve these systems algebraically and see what happens. Let's start with letter D. Because we have an isolated variable, the x, it is best that we start with trying to do substitution. So again, substitution means that we put this in place of the x. Right? Anywhere we see x, we're going to put that in this system. Thus we have 3 times the quantity of 2y plus 6 minus 6y is equal to 18. From here we distribute. Again, this gives me 6y plus 18 minus 6y is equal to 18. Combining like terms then, we see that we have our y's cancel to give me 0y, and I'm left with 18 is equal to 18. The question then is, what does this mean? Since the x and y is canceled, if the variable is canceled, the question is this statement true? Does 18 equal 18? Since it does, this implies that every x and y value that works for the top equation will also work for the bottom equation. So it doesn't matter what x and y value that work here that I put in, it will also work here, meaning there is now more than one answer that works. Since this is a true statement, every x and y coordinate works on the one equation will also work on the other. This means that there is an infinite number of solutions. When this happens, when my variables cancel and I'm left with an equation that is true, we call this an identity. Graphically, since I have infinite solutions, that means that these two equations have to be the same equation, meaning that we have coinciding lines. So algebraically, when your left side equals your right side after the variable is canceled, we call that an identity. Graphically, you would have seen coinciding lines, and this means that my answer to this system of equations is infinite solutions. Now let's take a look at E. If you haven't done so, take a moment and try to solve this problem and see how it presents itself. Otherwise, here's what this looks like. On this problem, I decided to solve this bottom one into standard form, getting the 4x and y on the same side and the -1 on the other. And then I still have the top equation, so I have 4x plus y equals 1, and then the 4x plus y equals -1. I multiplied the bottom equation by -1, giving me -4x minus y equals +1. I then eliminated my x's, which also eliminated my y's, giving me 0 equals 2. So now, what would that imply about how many answers we have? Since my variables canceled again, but this time this left side does not equal the right side, this is a false statement, this means that there is no solution. Algebraically, we call this a contradiction, and graphically this means that these lines are parallel. So if we solve a system of equations and my variables cancel, but the left side does not equal the right side, algebraically that's a contradiction. If you graphed it, you're seeing graphically that these lines are parallel, but ultimately the answer to this question, how many solutions are there, or what are the solutions? There are no solutions. In this problem, we will solve a real-world system of equations. First, we need to set up our system of equations. The problem reads, a movie theater ticket has tickets where the child tickets are $3 and adult tickets are $7. Last night, they sold 345 tickets for a total of $1,535. How many child and adult tickets were sold? The phrase, how many, tells us that this is where our variable is going to be. So we have child tickets and adult tickets. This represents our variables. So we know that children tickets, which we're going to represent with C, equals the number of children tickets, and A represents the number of adult tickets. Now that we have our variables, we need to figure out what were the topics that this problem was talking about. We see that there are children tickets for $3 and adult tickets for $7, totaling $1,535. This means we can write an equation in terms of money. So we write 3 times C plus 7 times the A is equal to $1,535. Next, we look at the number of tickets sold. We see here that there are 345 tickets sold. The number of tickets then for the children is represented with C. The number of adult tickets is represented with A. Therefore, we can look at the number of tickets as C plus A is equal to the total of 345 tickets. Notice we lined up our C's, we lined up our A's, and we have our constants on the other side. Now that we have our real-world equations, we can solve using any of the 4 methods we know, which is graphing, substitution, elimination, or matrices. You should be able to solve using any one of these methods. It would be great practice to do all 4 methods. In any case, you should end up with children tickets being 220 and adult tickets is 125. Take a moment and set up this equation and then try to solve it. Here's the answer you should have got. Should have gotten 180 children tickets and 340 adult tickets. If you didn't get that answer, go back, make sure your equation's correct, check over your work. Otherwise, ask for help.